Hello again, and welcome back to another Rhino tutorial. Today we'll be covering geometry modification. The first command we're going to cover today is explode. So you can see I've got a simple square here, and we're going to type explode. And what this does is it takes our polyline that was 4 segments but 1 polyline and breaks it down into its constituent parts. So now when I select this, we're going to be able to select each line individually. Now let's say some of those parts I want to remain together. I can select those again and then type join. And now we can see that our 2 individual line segments have been joined into one polyline. Say I want to alter my geometry a little bit by moving this out. And I want to make this a closed shape again. One of the things I can do is select everything, type join. Now this is one continuous curve, but it isn't closed yet. So I can type close curve. And now it adds a little segment that closes this shape. So that was pretty basic. Now we're going to take a look at what happens when we have 2 shapes and we want to perform operations on how they intersect. So I have 2 overlapping shapes here. I have this trapezoid shape and this triangle shape. And let's say I want to cut the trapezoid with the triangle. There are many different ways to do this. The first one we're going to cover is split. I'm going to type split into the command line. Now it's going to ask us which objects do we want to split. So I want to split the trapezoid, so I'm going to select the trapezoid, then hit enter. Now it's going to ask us which objects do we want to cut with. So I'm going to use this triangle to cut the trapezoid. I'm going to select it, press enter, and now you can see that the trapezoid has been cut into 2 different pieces. It's worth noting that split leaves both pieces remaining. Let's take a look at a different way to do that. So both our objects are whole, and now we're going to type trim. So trim is going to ask us for the cutting object first. So I'm going to select our triangle. I'm going to hit enter. Now it's going to ask us which parts that we want to cut. So I want to cut this part of the trapezoid off, so I'm just going to click it, and that part gets trimmed off. Press enter, and now we're left with only this part of the trapezoid. But let's say rather than cutting this trapezoid with this triangle, we want to divide the trapezoid into equal pieces. The command we'll use for that is divide. Divide is going to ask us where we want to start the division. Right here, the seam is here. I'm going to drag it back to this point. Then I'm going to hit enter. And divide has different options. We can choose to split this geometry into 5 different pieces. We can choose to just mark it with 5 points. And we can also choose to group the output. So I'm not going to group output, but I am going to split. We can also choose to divide, instead of with a number of segments, by a given length. For this example, we're just going to say we want this split into 5 segments, and then we're going to press done. So now, if I click on this object, you'll see that this curve is split into 5 different pieces. So we've covered the basic ways to cut curves. Now we're going to look at some of the different modifiers we can have for curves. Let's say I want this shape to have rounded edges. The command we're going to need is Fillet Corners. Now, Fillet Corners is going to ask us what radius we want to round these corners at. And 10 is a bit much for this curve, so I'm going to say 2. And now you can see that it's filleting this curve by 2 units. Let's say you didn't want to fillet all of those corners, and you only wanted to fillet 1 corner. The command you would use is just fillet. Now, it's worth mentioning that there are some options over here for fillet. We can choose to join this geometry after it's filleted, which is what I'll want to do. And we can choose to trim off any parts that shoot past the fillet, and we're going to choose that as well. The radius here, I'm going to use the same radius from last time, which is 2. And now I'm going to choose which curves I want to fillet. So I want to fillet this corner right here. It's worth noting that if the curve is joined, you have to click the corner, so something like this. But if the curves aren't joined, you have to select each curve individually. Now, let's say I'm happy with how this geometry is looking, but I want the outline of how these shapes intersect. One of the things I can do is the curve Boolean command. So I'm going to select all of my geometry that I want to use and type curve Boolean. And now curve Boolean is going to ask me a couple different things. So by default, it's going to come up with this little tooltip. I'm going to be able to click on the regions that I want to keep. And when I press enter, it will combine all of those things. I can choose to combine the regions like they are now, or I can choose to not combine the regions, and then they will stay as individual regions. I can also choose to delete all of the input geometry by coming over here and selecting all. I can also delete only the input geometry that was actually used in the curve Boolean process. For now, I'm going to click none. And I'm going to keep combined regions selected. I can also make this output a curve or a surface. But since I'm going to use all regions in this example, I'm just going to hit all regions and it'll do the work for me. Now I can hit enter. And you see that I have the outline of that shape selected. So I can now take that outline as a different piece of geometry. There's a similar command to this called hatch. So we're going to select this geometry again, type hatch. And now the difference between curve Boolean and hatch is that hatch will fill this space with a color, whereas curve Boolean will just give you an outline. So hatch, we can choose a solid color, or we can choose any of these different styles that we went over in the previous video. You can even load a hatch pattern from a file or from more standard hatch patterns. But right now, I'm just going to set it as a normal solid color. It's worth mentioning that we can select the hatch geometry in the same way that we were doing with curve Boolean. If I click boundary here, it's going to let me choose which areas I want to be hatched. But by default, it's set to use all regions. So we're going to hit OK. And now you can see that we have a solid color that is that entire space. Now, one of the things that can happen when you're modeling, especially if you're working in perspective view, is that it's possible for this shape or any shape you're working with to accidentally get dragged up in the Z direction. And if you're working in 2D, this is going to be an issue, especially if you are trying to make some kind of hatch geometry. If this curve becomes non-planar, or if it is elevated above some other curve you're trying to get it to interact with, if we go back into top view, you're going to have a hard time splitting, hatching, and doing any of those previous commands with this geometry now, even though it looks fine from top view. So one of the commands that we can do to fix this is to select these objects and then type project to C-plane. Now it's going to ask us, do we want to delete the input objects? For this case, yes, because these objects are all wonky and we want to flatten them so we can work with them normally again. In a case that you wouldn't want to delete the input objects is if you had some kind of 3D curve that you just wanted a 2D view of temporarily, you could do that. But in this case, we're going to say yes. And now, if we look in perspective again, this shape is back flat how we want it to be. So project to C-plane is a very good debugging tool when something isn't working. You can also project surfaces, and there are many different kinds of projection commands in Rhino, but since we're sticking mostly in 2D right now, we're just going to go over project to C-plane. One of the other debugging commands that is just about as useful as project to C-plane is called rebuild. So right now we have this curve, and this curve has a curved piece and some straight pieces. if I type rebuild, this interface will come up. And this interface is going to ask me how many control points I want to rebuild this curve with. Right now, there are 12 control points, which you can see here in these parentheses. By default, it's starting with 5. So let's say I want to rebuild this curve with 7 control points. When I type 7, the preview here is going to update. And this is what that curve is going to look like if it was built as a curve, not as a polyline, with 7 control points. Now we can change the degrees of this curve. And the degrees are referring to what type of curve it is. If we do a degree 1, this curve stays as a polyline. And if we do a degree 3 curve, it is a sinuous NURBS curve. Just like in other commands, we can choose to delete these input objects, create the object on a new layer, or preserve tangent directions. This master curve option here is kind of like match in the hatch parameters. So if we press master curve and then select a curve, it's going to take on the properties of that curve. So let's select master curve and we'll select this triangle. Now you can see that the shape here is inheriting all of the information from the curve that we selected. So our triangle had 3 control points and it was a degree 1 curve. And now you can see that we have 1, 2, 3 control points, and it is very obviously a degree 1 curve. This example is a bit extreme because our triangle is really nothing like our trapezoid. So for now, I'm going to hit cancel, but you can see that rebuild has a lot of flexibility and can be useful when you're trying to work with curved geometry. The last thing we're going to cover in this video is scaling. So there are many different ways to scale geometry in Rhino. The most common one that you're familiar with that we already went over in the user interface tutorial is scaling with Gumball. But now we're going to go over scaling with different commands. So the most basic one is scale. Scale is going to ask us for a beginning point and an end point. So wherever we select as the beginning point is going to stay the same. And then the end point is going to change. So as we drag this endpoint out or in, the shape will grow or shrink. Now we can come over here to this interface and ask scale to create a copy of our original geometry. If we do that, every time we click, it will make a new copy of our scale geometry. If we click rigid here, you can see that it is just scaling the boundary that these shapes take up. So when we drag it out, those shapes are moving either closer or farther together, but their size is always staying the same. If we were to select neither of these, all we would do is click once to confirm, and then this is our scaled geometry. But there are also other kinds of scaling commands. For instance, we can type scale 1D to scale in only one dimension. It's worth noting that we have the same options here. Now, it's going to ask us for a base point, just like scale did. And we can scale just like we did with scale before, but now it's only going to scale in one direction. I can do that again, but instead of scaling the way we were doing before, where we pick 2 points, I'm going to choose to scale it with a reference scale factor. Say I want to scale something by double. I'm just going to come over here and type 2, and then click done. Now it's going to ask me what direction do I want to scale it by double in. So you can see that as you move your mouse, the direction will change. So as soon as it's in a direction that you want, just click again, and the command will finish. So that covers the majority of geometry modification. In the next tutorial, we're going to be talking about movement and duplication.